So before we get too much further, one thing that's going to be important is this idea of passing by reference and passing by value. So when I say passing by reference, I'm looking particularly at this ArrayList path. When I call traveling on path, it doesn't make a copy of it when it calls traveling again. So when the recursion happens, it's actually passing a pointer to the same path thing over and over again. So when I return, if I've added things to the path, they will still be there. So when I return, I have to make sure that I remove the last thing in the path. And the same is true down here. So that when I back up, I don't have an issue where the path is just constantly full and I can't find any other ways through. So that turns out to be important. The reason that matters and is different is that the integer here, this total, it actually makes a copy of whatever this number value is and puts it in total. If I change this total value within this part here, it actually doesn't change it for all the previous versions of traveling like it will with path. So the basic idea is that passing by reference, any object that you have, it's actually pointing at the same object every time. It's not making copies. Whereas any kind of primitive type, it actually does make a copy, and changing this copy doesn't have any effects on the original value. There you go, reference, value. You'll see that again in C++. All right, now there's one tricky thing that I would like to take a look at real quick, which is how do you know what's at the other end of an edge? That's not a non-obvious thing to do. Basically what I'm going to have to do is look at both nodes and see if I'm one of them and give back the other one. I probably should have a method that deals with that. So let's create that in Edge. So public node get other end. Sure. So the idea with this is that I'll pass in a particular node and I'll check to see if it's first or second, or if it's neither. So if I have a particular edge and I say, all right, is first equal to n? If it is, I need to return the other end, so I'll return second. Otherwise, if second equals n, I should return first. And then there's always the lovely problem of, well, what if it's not actually part of this edge? Then I'll return null. And I'll have to watch out for that. So I can use this getOtherEnd method now to take care of that. So the general idea with this one will be for each edge in your edge list. I don't currently have that, so you'll get to ignore errors for a little bit. Then we're going to see if it's connected to the current node. So let's do edge E is edgeList.get a. So with a particular edge, I can then say get other end. If we don't already have that in our path. And it's not already in the, so if it's not in our path already, then we're going to call, basically add the other end into our path. We're going to call traveling again on that. So that's the node we'll then be looking at. We'll just pass our path along again. And then total will be total plus whatever is currently the label of our edge. Integer parseInt e.getLabel. So remember, the edge's label is the thing that has the number on it when I'm running it. There is that for you. So you need this part here. You got to watch out for removing things from the path, and you may need to create getters for these. That's the basic idea with traveling salesman. The only other thing you have to do is you're going to have to walk through your completed list and print it out when you're all done with whichever one is the minimum number. You have a couple of options here. I'm passing along total, so you could add total in somehow to another array list, or you could put total in with the path. That would allow you to have total be in with whatever your path value is. Or alternately, you could just walk through each of your paths and recalculate it again. Once you have once you've done your traveling, which is, there it is. You're going to find I guess first, make sure completed has a path in it. If there are no paths, there's actually no valid way of getting through it, and so you should say that. If it does have a path, then what you're going to do is find the shortest path, print out its value and the path itself. So the series of nodes that you need. Lots of comments because I'm making you actually code this one up, but this is the general algorithm. Good luck.